Good morning, ma'am, Satansi ma'am, and respected chairperson and resource person in this conference who is organizing. And thank you for all who is giving in the conference team who give the opportunity to present my presentation here in the International Day of Women in Statistics and Data Science, IDWSDS. This is a virtual conference and I'm organizing the 10th October 2023. This is the World Statistics Day also. In this day, this is started the first World Statistical Day in 10th October 2010, and it is the almost 13 year of the celebration of the International Statistics Day. And I am here presenting the few of the female statisticians, statistician of Indian, and who is working as well as another countries, that is like American and another country. So here is the Indian statistician and the Indian American statistician, and I am presenting a few of the name who is gives the her very important and most significant contribution in statistics. So the first one is the Dr. Mahabanu Tata, and she is Indian statistician, and this is Parsi, and she is the born period is 26th April 1942 to the current last 7th August 2023. She has completing their lifespan, and she did PhD in 1967 from Purdue University and working Iran Azad University, and she is the founder of statistics in Iran. She is the founder of statistics in Iran. And second one is the Rajeshwari Sundaram. She is also Indian American statistician. She is biostatistician, Indian, and she had the expertise in the survival analysis, and she did in a graduation in the University of Calcutta and masters in Indian Statistical Institute and PhD Michigan State University. And next one is the next statistician is Dr. Nagambari Shah, Indian American statistician. And she is originally from India, and she had completed her graduation and master from Indian local university and PhD from in 1970 University of Eurostat, and working in 1972 Spelman College Mathematics and Mathematics department. And fourth one is the Dr. Lalitha Padmanabh Lily Sanathan. She is Indian American statistician, and we are currently working. Our team is also currently working in the estimation of species problem, and her contribution in the estimation of the population size is very significant. And she did a PhD in 1969, University of Chicago, estimating, and the title of the thesis is the estimating population size in particle scaling context. And after that, she is working at the University of Illinois, Chicago, assistant professor, and many novel work he did in his lifetime period. And also the very most important thing, she is spending most of the time in the clinical research organization, and she founded the two of the very known industry, that is the CleanWorld and StatLink, that is currently working in the very big known in the clinical research team. And many more of the female statisticians, that is the Dr. Nalini Shivsankar, Dr. Kavita Ramana, and Dr. Harman Mukherjee, and Dr. Marjot Kaur. And Dr. Marjot Kaur belongs to the Punjab University, and her expertise area is the stochastic and also the clinical research, and she did it. And she is the president of Indian International Statistical Association, and the expertise area is the biostatistics. And next is the Dr. Susmita Datta, and she belongs to the Bengal, and currently she works on the prestigious university, University of Florida, and University of Georgia State University of Florida also. And last is the Dr. Ranjana Dasgupta. She is Indian statistician, and she completed her graduation from Presidency College Kolkata, and master from University of South Carolina, PhD from University of South Carolina 1996, and she is working as the faculty position at Washington State University. So these are the very big name in in statistics from Indian community in the international level, and this is playing a very important role. And in this, the fourth one is the Dr. Lalita Sanatana. His contribution is the very ultimate, and her contribution in the estimation of the number of species. And currently we are working in the topic, and this is the very interesting topic. And the title of the my presentation is the sample size estimation for the epidemiological and medical studies. Because of that, I am choosing this problem because I am currently working in the medical study at Dr. Ram Manohar Institute of Medical Sciences, Lucknow, India, Uttar Pradesh. And this theme is very interesting for the designing of the protocol, designing of the survey, and designing of the research. So the sample size estimation is a very important role plays in this. So we are basically I'm here presenting sample size estimation is a critical step in research planning and design phase, and it is the optimal sample. It requires the optimal sample size for a study that assure an adequate power of test to detect statistical significance. So here is the adequate power of test, that means that this reduce the false negativity and increase the statistical significance. That is the level of significance. If this is the balanced approach, then we get the optimal sample size. And this plays the important step in research to design protocol, like thesis protocol design and dissertation protocol design. So this plays the very important role. And to determine the sufficient participant in a study that have optimal cost, time, and exposure. And sample size calculation depends on study design. One sample and two sample and more also have a measure the study variables. And it explaining some circumstances and basic principles to calculate sample size in medical and epidemiological studies, because here the basic principle, that means we have the study designs like the descriptive study design and interventional study design, and descriptive study design is the cross-sectional study design, cohort study design, and prospective and retrospective study design, and case control study design. So these are the study design. On the basis of that, we are calculating and formulating the sample size. And also in the various fields like basic science, health science, social agricultural science, engineering science, and management, they also require the that may process, and decisions are totally dependent on the data, and 100% inspection is impractical or impossible to get the feasible, and it is based on the cost and other errors, and to collecting the data that based on the sampling and their associated risk, that is the tolerance level that management involves and decision making from limited data. From population to sample, it is the subset of the population. And why the sample size calculation is important? Because it is the required the some properties, that is the representative and statistical power, precision, generalizability, reliability, validity, subgroup analysis, and resource allocation. So representative means the population has the larger number of the individuals, and we are selecting the subset of the population. So that is the representative of our study. So representative of our study, this means that the characteristics and behaviors of the sample are more likely to mirror those of the larger group. Without a representative sample, the study findings may not accurately apply to the population. So here is the very important thing: the samples should be representative. And next is the statistical power. So sample size impacts the statistical power of a study, which is the ability to detect the true effect or differences when they exist. Larger sample size provides greater statistical power, making it more likely to identify real effects. The smaller samples are less powerful and may fail to detect important reasons. So in this situation, now the more large sample size is required, less number of observations in the sample are required. So it requires the optimal sample. And the statistical power are the plays very important to get and to reach the optimal sample size. And next is the precision. So precision is also known as the margin of error. And margin of error is the error of the in terms of the error is calculated on the basis of larger the sample and more precise the results. So error is the we have the observations, we have the set of observations, we are calculating the maximum and minimum type of minimum errors, minimum observations, and differentiating them, and we get the margin of error. This precision is important for drawing maximum meaningful calculations and making accurate predictions. So the margin of error is also very important to calculate the sample size and generalizability with a sufficient sample size. The study's findings are more likely to be generalized to the broader population. Researchers can have more confidence that what they observe in the sample reflect what is happening in the larger population. And the system reliability.
Hello.
Yes.
Yes, ma'am. So there was some networking problem, ma'am.
I can see that. Okay, Manoj, do you want to start presenting because the next session will start soon. So just give us a overview, summary. So you can present for some time, and then Sandeep can present for some time.
Ma'am, he only Sandeep pertaining to Anurag Pathak is hello.
So these factors are affecting the sample size calculation in the population, which population is finite and infinite, and availability of resource, that is the time and manpower, and the sampling method is required, that is the simple random sampling, stratified sampling, systematic sampling, and cluster sampling is required, and confidence interval, that is the level of significance 5% is also required. That is in margin of error, that is previously, and variability. The variance or standard deviation for sample size calculation is obtained either from previous activity. So these are the and effect size. Effect size is the difference between two independent groups. That is the mean and proportions like that. So we are observing, we are collecting these information from the previous available studies. Then we will able to calculate the sample size. And optimum sample size require the situations and to allow the appropriate analysis to provide desired level of accuracy to allow validity of significance test. And method for determining the sample size is the arbitrary approach. In this arbitrary approach, we are approximately considering the 5% to 10% of the samples from the total population. And conventional approach, it is the average sample size of previously conducted studies. So we can consider the single sample size. And cost benefit approach, here we are mainly focused on the time, manpower, and resources. And fourth one is the statistical analysis requirement. Then in this approach, we are required the statistical techniques, and in this approach, we require the optimal outcome of the variables. And last one is the confidence interval approach. So in this approach, we are required the amount of variability and desired accuracy and level of significance. And we have the formula for that is the n equal to z square alpha into sigma square over e square. Sigma square is the variance of the study, and
hello,
there is the sigma graph.
Anurag sir, can you stop your sharing? I would like to invite Sandeep sir.
Okay, so within 1 minute I finish it. So these are the questions, examples that I discussed. So here is the formula, we put the value and obtain the sample size, and this is the using the R statistical software to calculate the sample size using the library PWR, and we obtain the sample size is this. And these are the references in this. And thank you, ma'am.
Okay.
Giving the opportunity.
Yeah. So Sandeep, could you quickly start your presentation? What's this? Anurag, please stop sharing, and Sandeep, please start sharing your presentation.
Good afternoon. Good afternoon to all of you. Good afternoon, ma'am. And good afternoon, organizer. I am Sandeep Kumar. Basically, I have chaired this organized session entitled Empowering Insights Celebrating Women in Statistics and Data Science. And my talk title is towards empowering data science, role of Bayesian inference using ecological models in species ecosystem management. Basically, this is a very important topic in data science and ecological modeling also. Basically, we have celebrated the International Day of Women in Statistics and Data Science and 2023. This is some overview of the role of women in data science. Okay, first lady of as you can see in this screen, first lady of statistics. This is Gertrude Cox, first lady of statistics. Cox, born in Iowa in 1990, Cox was the first person to earn a master's degree in statistics, and in 1931, she was the first female professor and department head of the North Carolina State College, where she led the Department of Experimental Statistics. She was also known as the first lady of statistics. Okay, next lady is Florence Nightingale. Which Nightingale was the first female member of the Royal Statistical Society. She was also the first woman to awarded the Order of Merit. Nightingale, okay, was to pioneer statistician who used to data to advocate the change. That was revolutionary. And some important role and women in different dimensions, say in this history in data science is not possible without women, and women's roles in a different area, like as researchers has very important role in new dimension in researcher. Okay, and next, contribution of women towards the data science. Here is a 33.3% global average percentage of female researchers researching in world in different dimension, and 30% of all the countries who data available on the national share of women researchers had reached parity in 2016. And here say that what would need science, but science needs women. Here say, as you can see in this screen, women has very important role in different dimensions, like as engineering, in hospitality, in data science also. Okay, now here is the main title is empowering towards empowering data science, role of Bayesian inference using ecological models in species ecosystem management. Basically, first of all, I discuss about ecology. Ecology basically has a green taken by green to origin, and oikos means house, and logos means study of the house environment in which we live. Okay, and the study of organisms to determine the distribution and abundance of organisms within a particular environment. Here is a level of organization, basically cell, tissues, origin system, organism, population, community, ecosystem, biosphere. Next, we discuss about species. Basically, my talk is based on estimation of species and how to management species ecosystem. So basically, species a group of organisms which can interbreed and produce fertile offspring. Okay, and our objective is, our aim is to study ecological models, abundance model under Bayesian paradigm. Next, how to management the number of species in any ecosystem and role of Bayesian inference in ecology, and to discuss the ecological models and estimation process have been performed on ecological data. Bayesian inference. Bayesian inference utilization from these pictures. Bayesian methods for analyzing data are now widely used in ecology and wildlife ecosystem management. Basically, a second point, Bayesian approach prior distribution, which represent the uncertainty about the model parameter. Okay, and background based theorem, basically based on very important theorem in Bayesian inference and based on real life situations. So Bayes theorem used the prior probability distribution and the likelihood of the data to present a posterior probability distribution. Bayesian inference using ecological models. Here are some mathematical formulation of Bayesian inference using ecological models. Select xi, the abundance of species I. Xi follows Gaussian distribution with parameter I. Without loss of generality, we take t equal to 1. So each means each species contributes portion and number. And just the marginal distribution of xi become F mixed Poisson model. P theta given P theta x equal to this. Okay. And background of these ecological models, basically in order to formulate the problem mathematically as follows in this process. Here are some mathematics likelihood function based on ecological models, and here this likelihood.
Good. Please continue.
Sandeep, you are unmuted yourself.
Yes,
Please
yes.
unmute.
Some likelihood suggested by Lalitha Sanatan 1972 to estimate the discrete parameters say theta, and here some formulation for above likelihood to this. Here LB is a binomial likelihood with respect to the random variable D. Say LC is a conditional likelihood with respect to the frequency counts. Say FK and model formulation based on say here we consider the gamma distribution, gamma mixed Poisson distribution. So model formulation for gamma mixed Poisson distribution. In real life application where neta is known or unknown, we must be estimated the data along with n under the F mixed Poisson distribution. And conclusion, the developed Bayesian financial procedure for the estimation of parameters of unexplored new lifetime models and P mixed Poisson model. Here the proposed procedure shall be based on the classical as well as Bayesian approach. And two, in Bayesian paradigm, the inferential procedure shall depend on assigned probability distribution, not only the observable data variable but also unknown parameters. Here we propose to develop some method for the study of the effect of choice of distribution on the estimation of the parameters. Next, we propose the classical and Bayes estimator for the number of species in a community using F mixed Poisson models based on various Bayesian methods. And next, after we will take data with the fitting Poisson models and present their applicability in ecology for species ecosystem management. Thank you.
Thank you very much, Sandeep, for finishing on time. And thank you, Manoj, for organizing this session. I'm extremely delighted that all of you managed to present within your time. So is there
Okay, thank you, ma'am.
Is there any question from any of you? I don't see any question from the audience. So Manoj, Anurag or Sandeep, do you want to ask any question about the research that you presented?
No, ma'am. Basically, we are a team. We are doing the same work in the team, so we have no question.
Okay, so all of you are doing the same work.
Yes, in a research team, basically, ma'am. So we are the same team. Basically, sir, Manoj sir is my supervisor, and I am the student of Manoj sir, and Sandeep is the next student. So we are the core team. So we are presenting here.
Okay, all right.